Hey there, amazing biology students. We're ready for the lab today known as Primordial Soup. Before we get started, I did want to note a couple of changes that I did make to the procedure. Down here under number 1, would you guys go ahead and make a change? Instead of adding 4 milliliters of the gum arabic solution, we're going to add 8. So that's going to be an increased number. And then on the back side on your data table, according to the protocol, there's been some revisions. So this is the number of drops of hydrochloric acid. When we do our first run, we're not going to add any drops of HCl, but look what we're changing this to. On the second run, we're going to add 3. On the third run, we're going to add 6 drops of hydrochloric acid. Fourth run, 9 drops, and fifth run, 12 drops. So please note that change in your data table. Because they have made some changes to the protocol at the AP College Board so that we can have the proper data come out of this lab. Okay, so just want to give you a sneak peek of what the setup looks like since you guys are not here to see this. I usually do this tray, which is a setup for 2 groups, one on either side. So some of the things are shared. So one of the shared things is the test tube rack. So each group is going to get a test tube like this. And the bottom of the test tube, that is the gelatin. Okay, these have been sitting overnight in the refrigerator. So there's a little bit of cool gelatin. That's approximately 8 milliliters of gelatin. I kind of put in there, I think I'd put a little bit more, put like 10. So each group is gonna have that. The other part of the shared is the gum arabic solution that you can see right here. I mixed that up, it's ready to go. We have shared, these are cover slips for the microscope slides. Okay, then each group has their own graduated cylinder to be able to measure out properly. They've got a pipette. We do have our pH paper. Now this is low range pH paper. When I say low range, it's like not the full scale because we're expecting the pH to be, between probably like a 3 and a 7 or neutral. So we can use this scale. So this is low ion pH paper. We didn't need the full range. We also have our bottle of hydrochloric acid. It's 0.1 molar, so it's really not that strong. I mean, it is strong, it's hydrochloric acid, but it's not like it's 1 molar, it's 0.1 molar. And then over here to do our slides, I've already pre-drawn on these numbers because they're gonna have one for each run. So if you can see, there's a 1 somewhere, here's the 1. So there's 1, 2, 3, 4, and 5. They're out of order right now, but that's okay. So the idea is, and you can see the procedure, and I'll take a video in a minute of them doing the procedure, but they're going to kind of try to get this primordial soup in this test tube. So we start with the gelatin, and then they're going to be adding the gum arabic solution and see how many coercivets we can form. And so we will be looking at this. It's exciting. Okay, so they're adding the gum arabic to the graduated cylinder according to the protocol, measuring out the proper milliliters.
Hand models.
Okay, so now they're gonna add the gum arabic to the gelatin test tube. Look how cool, ooh, pretty. So that was 8 mils, right?
Mm-hmm. Yeah.
8 milliliters of gum arabic to the gelatin. So now they're inverting their test tube, trying to mix the 2 together, gelatin and gum arabic. That's nice concentration. That's really good. So now they're recording observations. So I'm going to zoom in on the tube so that y'all can see. Ooh, look how pretty. So this next part, they're about to test the pH without any hydrochloric acid. So they dip the stir rod in. Look how beautiful that is. They're going to touch it to the pH. Ooh, nice. Look at that change. And they're going to compare it to the chart. So while y'all are doing that, I'm going to let them look too. Ooh. Which one do you guys think it looks close to?
I feel like it's like in the middle there.
It could be in the middle. You can do a 0.5.
But then it's not bluish.
Right, I agree with you. It's more green, right?
Yeah. Yeah.
Is it closer to the 5?
I think so.
Yeah?
Yeah.
It's not the 4.5, huh?
Mm-hmm.
Across the way. I think I agree with you. I think it's that one. Yeah, that looks pretty good. Let them see. That looks like a good match to me. So that's a 5, right?
Mm-hmm. Yeah.
So I'm going to let them, go ahead, you can write it down. So they're recording the 5 for the pH. Okay guys, so what they're doing now is taking a sample out of the tube that they know has a pH of a 5, put a couple of drops on the slide, and what they're gonna do is use the microscope to see how many coercivants are in the solution at a pH of 5 before adding any hydrochloric acid. So they're looking for their cover slips somewhere in there. Sometimes they stick together too, they're thick, but they are gonna use a cover slip on this to make sure that they don't make a mess. Beautiful technique, look at that. You know that has to be nerve-wracking when the teacher is like videoing you. Awesome. So they've got their cover slip. Now they're ready. They're going to use their handy-dandy microscope. Now, just so y'all know, I told them that for this lab, the little baby, I call this the baby power. It's a 4, that they might want to start off on that because sometimes you can see better the lower power because the coercivants may be a little large. So they're going to start. Okay, so they have it on their 4X. I'm going to attempt to show you guys what this looks like. This is very hard to do with the camera. Bear with me. Once I get it focused, you may want to push pause because you'll see. There you go. You see at the end of the pointer, can you guys see that? Like they're going to answer me. Hang on. I hate this part of doing this. But so now they've added their drops. How many did y'all put in that one?
3.
3 drops of hydrochloric acid. They're inverting it, and now they're about to test the pH again.
I feel like it's this. Yeah, like you want.
Now they're very good about their protocol, so they're wiping off the plaster rug to make sure there's no contamination. That's good procedure, y'all. Okay, now they're gonna see if their pH by adding the 3 drops has changed.
I feel like it went down. I feel like it's darker.
Yeah, I think you're right.
Yeah, it's weird.
Looks like it dropped to 0.5, right?
Yeah.
Okay, so that's after adding 3 drops. So all you guys record your data. Okay, so they're recording observations on this after adding. That's not easy to see. Put it on the black maybe so they can see. Oh, there we go.
I think we do this.
You guys can see up close. Record your observations. All right, so now they're ready for the second view. This is slide number 2, and they're gonna see if dropping that pH is going to do anything to the number of coercivants. Okay, y'all, so can you look to the right? You see that circle over there to the right? And then there's one, it's hard to see, but there's one to the left.
You know?
You guys aren't gonna be able to see it, but at least you can see that one to the right. Y'all, I got it. What? Line number is the bomb. So record 2 on your data table.
I think like the more.
Okay, so now they added 6 drops, right? Woo, look at that. Record your observations, people. That was looking pretty cool. So that's 6 drops. So this is gonna be run number 3. Okay, so now we're testing pH for our run number 3. Okay, we're doing run number 3.
That's a big one. Yeah.
Ooh, that's a beautiful match. Can y'all see that? Okay, now move it over a little bit so they can see the number, even though we know what the number is. That's a 4. Okay. Okay, so I want y'all to see this. You're gonna be so amazed. I get excited with science. Go ahead and count those, why don't you? Look at all those coercivants.
It would be like a 3.5.
Wait, let me get a good view. You might want to push pause when I get it in view. Y'all are like, Miss Lynham, you're terrible at this. There you go, there you go. Ooh, 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 ooh. Look at that. I did it. And just so you know, there were 21 in that field of view. Do you hear me? 21. Record that. Get up the pace now. So we are now ready for run number 4. We've added 3 more drops. She is inverting the tube beautifully. Awesome sauce. And now we're gonna record the clarity. There you go. Way cloudier. Look at that. Lots of chunky monkeys. Now they're gonna test the pH for this run number 4. See what they get. My prediction is it is gonna be majorly acidic.
Did you wipe it off?
Yeah. Let's just see.
It kind of looks the
They're
same.
touching the.
Just like really cloudy, no foam.
There's the glass stir rod.
I'd just say more cloudy.
They're gonna put that in to the tube. Touch the paper.
Hello? Wasn't that doing anything?
Probably because look at the yellow on there. I bet it's gonna match one of these. Well, you could put another drop if you want, but it may be very acidic, so it's matching like the. It might already be at a 3 or a 3.5. Yeah, it's gonna be one of those two. Question is, do you think it's still got a little bit of green? Yeah, that's what I think it is. That's my prediction. 3.5. It's got a little bit of green in it still. Yeah. All right, so on this round, they counted 30. We're gonna take their word for it, but I'm gonna give y'all a shot just to look. Check it out. Oh, Miss Lynham did it right away. What? Oh, yeah. So 30 on that round. So now we're ready for the finale. We're on the last run. Run number 5. Morgan's adding the amazing HCl. Last number drops, there's 12 now. Okay, she's inverting. This is gonna be very acidic. Goodness. I know. Okay, here's your observations. Wow. It's not quite as clumpy, huh? It's just cloudy. Okay, so there's the final pH. They have it drop down all the way to a 3. So now they are about to make their slide.
I don't even think it's allowed.
Yeah, really? That's kind of.
Say something.
He's probably not gonna care.
Oh, smart. She wanted to get the air bubbles out so as not to have air bubbles and only have coercivets. Good job. Shot 3.
So I think that's why it wasn't clumpy this time.
Exactly. Yep. Okay, so y'all, in this final one, we only counted 1, and it's to the right of the pointer. You can see it right there, to the right. So what we were talking about while I'm trying to find this. Let me see if I can see the 1. This is there it is. Ooh, there it is, there it is, there it is, to the right of the pointer. Okay, perfect. So what we were talking about, and you guys up at the front can hear me say this too, you'll notice that some people had a decrease in the number of coercivets as we reached a more acidic level, but you have to think back to proteins, right? Remember, enzymes work best within a narrow temperature and pH range. So at some point, if we had polymers of proteins formed, it's possible that if the pH became too acidic, that it started to break down the polypeptides as opposed to help build them. So it is possible that you have an increase up to a certain pH level that drops, and then the number of coercivets decreases because you go beyond that ideal level. So be thinking about that, because that goes back to biochemistry, which this whole lab is based off of the chemistry of life in primordial soup. Okay, so all you guys who are virtual, on this column right here where it says hydrogen ion concentration, what I told the kids in class, remember that if it's a pH, this goes back to biochemistry, if it's a pH of 7, do y'all remember how the hydrogen ions are equal to hydroxide ions? And at a pH of 7, the hydrogen ions are 1 times 10 to the negative 7 power, and the hydroxide ions are the same thing, 1 times 10 to the negative 7. So if we drop the pH right here, we drop it and it's a 5, then the question is, what is that going to do to this number if we go from a pH of 7 to a pH of 5? And you can put this answer in decimal form if you want to. You don't have to record it as the 1 times 10 to the negative 5. You can actually do it in decimal form.